Awesome. Great to have you all here. Today we're going to be discussing the scalability challenges, interoperability within the Ethereum ecosystem. We're going to talk about a little bit about the fragmentation and all that. Today we have a amazing panel here with all the people involved in that interoperability goal. We have Avi, sorry, not Avi. We have Jordi, the co-founder of Polygon. We have Avi, the CEO for the NIL Foundation. We have Barnabas, the co-founder of Malda, and we have Declan, the product lead for Linea. So let's start off by giving a brief introduction about yourself and what you're doing to address the scalability or interoperability issues for Ethereum. I guess starting with Jordi.
Yeah, well, we in Polygon, we are building the aggregation layer. That's mainly it's a scalability solution. It's interoperability between chains. And I would say that probably the most important thing in the aggregation layer is that we are trying to keep sovereignty of each of the chain that composes the aggregation layer. And at the same time, trying to reduce as much as we can the friction between the transfers between the chains. And for that, I mean, you need to develop some technology. zk, of course, is a fundamental piece to achieve this piece. And this is very much what the idea of the aggregation layer in Polygon and what we are trying to build there.
Hi, my name is Barna. I'm one of the co-founders of Malda, which is a new unified liquidity lending protocol. So we also saw that liquidity fragmentation is quite a big issue. And our solution relies on zk proof-based interop between the contracts that are deployed on different chains to verify that the user actually has enough collateral globally to borrow against it. And we are approaching it from an application point of view. And in the future, we are also hoping to scale up operations further by building in the zkVM, which is zero boundless. We have like 100x unlock there from the app side to make it more efficient.
Testing. Ooh. Yeah, hi everyone. I'm Declan. I'm head of product at Linea. We're just building a zkVM layer 2 rollup technology stack. We've actually handwritten all the constraints for the EVM, so it's incredibly performant. Our goal is to basically have the most scalable zkVM like rollup tech.
Cool. Can you hear me? Yes. Hi, I'm Avi. I'm the CEO at NIL Foundation. We built the first sharded rollup, and we fundamentally believe interop is a problem of control. What that means is you can't let everybody go off and do their own thing and expect that everybody else is going to follow. So we've built an interop solution into our rollup. That's why we call it a sharded rollup. We treat every shard as just an execution environment that is unified across many shards, and developers can write programs that run in a distributed fashion. And we're live in testnet.
Amazing, amazing. I guess to start off with the question for specifically that fragmentation piece within the L2 space. So L2s are meant to solve the issue of either scalability, privacy. I guess it's an additional layer. But we've seen like a lot of L2s within the space essentially pop up. In terms of this direction, it looks like we're headed towards an expansion of fragmentation. So I guess how are your projects making the L2 space more interoperable, or I guess less fragmented? I guess starting with you, Avi.
Sure. Yeah. So I think it's important to recognize why we ended up with the rollup-centric roadmap, which really the impetus was how do we achieve horizontal scale, which I think everybody on this panel will probably support. That in order for us to build a global financial system, we need the ability to linearly scale with additional hardware. We cannot simply fit everything through one server. Now, Ethereum's original vision of doing this was sharding. And what that meant was you ran many Ethereum chains in parallel, and they all operated within a single protocol. Now, sharding is and this is no secret, a very complex system to build. So we ended up with a rollup-centric roadmap where everybody was sort of spinning up their own servers, and we still got this kind of loose definition of horizontal scale. The issue is these aren't the same system, right? We're spinning up isolated systems, and this is where folks like Polygon are coming in and kind of building an aggregation layer that can maybe bring all of these isolated systems back into one. At NIL Foundation, we're very hopeful for that, and we hope ag layer and shared sequencers do really well. But we also recognize that the political coordination game is a 10x or 100x more difficult problem to solve than just the engineering one. So we've built what was essentially the original vision for Ethereum scaling as a layer 2, which is a sharded rollup. And we ensure that there's interop between all of our shards in perpetuity at a protocol level.
Here, I think this is important because probably there is one difference in here that in the aggregation layer, there is a big important difference between the sharding model and the aggregation layer model. Is the shardings, all the shards are the same. All the shards are safe, they follow the EVM, and they are, they have the same properties. Okay. The idea of the aggregation layer is that we are trying to break that. The idea is that each chain has their own properties. May have a different centralized sequencer or decentralized sequencer, maybe Validium, or they want to have data on chain, or even they may be EVM or something else, maybe, or it can be some that they have they have some privacy built on top of that. So, and the idea is that what we are trying to see is, okay, what's the minimum things that a chain needs to guarantee in order to be able to transfer funds and to transfer value between the chains. This is what we call the pessimistic proof, or is a proof that mainly what it proves is that when the chain is sending funds to another chain, so one user of a chain is sending funds to another chain, that the chain has enough funds locked in there. So maybe the chain can be a malicious chain, can do maybe a centralized chain. A chain can be somebody that's just saying what's the next state, but in the coordination, but this malicious chain cannot affect the other chains. They isolate the chains. And you can and here you can have examples, for example, of private rollups. A company that just is running their rollup. They want to. The cost of maintaining that is going to be slower, and the security requirements there. So no, and this is, I think, this is one important difference in the model of the sharding and the aggregation layer. Totally. What's the best? I don't know. We are betting on this one, but
it's just a spectrum of trade-offs, right? And you're totally right. We don't offer any customization for developers at for the execution environment. There's no customization for DA. We believe that the network effects that you get of essentially a unified execution environment and the expressivity that a single virtual machine can offer you is sufficient and better for call it 85-90% of applications. And we've seen this, happen in the Solana ecosystem across the SVM. We've seen it happen on ETH L1, as well as, across all of the other essentially L2s that are running, identical copies of the EVM with very, very little, marginal differences between them. So, a big trade-off that we make is, we're not for customization at the infrastructure layer, but the benefit is that we are able to ensure interop in perpetuity.
Can I say something controversial? I don't think there's going to be that many chains. There's going to be, in my opinion, 3 to 5 extremely large, vertically scaled L2 rollups. And then you're going to have a sort of middle ground with some enterprise multi-party business use cases. I think Jordi was alluding to those earlier. And then this sort of long tail with app chains that we see today, they really make no sense to be on a blockchain. At best, they can be handled by a zk coprocessor, very similar to a Lambda function in Web 2. Alternatively, they should just be a smart contract. And so this idea that you're going to have thousands of chains, I don't believe in that future. I think the sort of vertical performances that we're going to see on these L2s are going to be able to handle large amounts of throughput. Not everything needs to go on the blockchain. A lot of current use cases are handling their technical architecture very poorly. We should only be putting things that actually require global coordination on the blockchain. And so the sort of numbers and the throughput that we can achieve of like 3 to 5 large L2s is going to meet most of the use cases that demand sort of global coordination blockchains. And so I think interoperability will be solved because we'll just see a lot of these like chains like die out, and interop between some large chains for even like intents is already very good today. Like I can move between Linea and base in like 1 second for 1 cent, because as long as there's enough assets and solvers there, it's pretty decent.
Yeah, I mean, I agree with that future vision. I also don't think there will be many rollups. The market trends are not going that way. And I think we can already solve most of the interop if we rely on state proofs. And I think what is required for the applications to really be built this way is more coordination on the infra level for quicker finality and more certain finality. I'd like, if you have an application that integrates Ethereum mainnet, it also needs to have make a lot of assumptions right now, depending on potentially value of the transfer. If it's a DeFi application, like how many confirmations do you want behind your zero knowledge proofs that proves that the state happened there? And that's also something that happens on layer 2, right? Like optimistic rollups have uncertain finality properties. zk rollups, in my opinion, they are better. It's a little bit easier to build on top of it, but the documentation also needs to be improved, because in our experience, building on multiple layer 2s and trying to understand the finality, many of these things are not yet well documented. So I think that's also very important.
I disagree. I mean, I think that it's going to be more. I mean, of course, none of us has the crystal ball here, and it's difficult to know. But I mean, if you see the number of, the quantity of economical transactions that happen in the world right now, and here we are not considering even things that could be microtransactions. I mean, transactions that could be done between bots or Internet of Things, and things that are small payments that probably could be possible in there. Maybe it's a matter of time. Maybe in the next 2-3 years, maybe you are right. But and maybe then the requirement, maybe the needs, the demand that we need right now, maybe it could fit in that. But if the ambition is to be the basic platform where all the economical transactions happen in the world, 5 is not going to be enough, and I would say 5,000 probably. I mean, it's and there is some intrinsic limitations, and maybe we need to go to the next bottleneck, okay? But even if you are trying to run Ethereum in a centralized way, I mean, just run just take the best server that you get, just simple centralize, and okay, what's the throughput on that, okay? And with that in mind, it's not even 1% or 0.1% of the transaction. I mean, it's nothing that the requirements that you would need when you compare the number of transactions. So in the long term, for sure, we will need systems. And it's important to have a model that scales beyond 4 or 5. I mean, it's a model that can scale as much as you can. I know that's early, and probably that would be great to have 5 that they connect very well. But in the thinking a little bit in a longer term, definitely we need a system where rollups can appear and disappear easily, and that the connectivity between these rollups and the friction between the transferring between these rollups is fast enough. Maybe the limitation here is what's going to be the bandwidth between the rollups, okay? But then here you can maybe double scale, but that's maybe long term thinking.
Yeah, so there's a variety of different perspectives of the fragmentations. I guess some perspectives we see it expanding. Like there needs to be support for many different types of rollups and ecosystems. But then others is like everything can be done within a zkVM or essentially did off-chain computation bring on-chain. So I guess like and then you mentioned social coordination within like the Ethereum ecosystem. I guess the next question is like is there things that can be done within Ethereum that would enable this ability for extending support? So I know like it was discussed some like pre-compiles for maybe ZK proof verification. But I know a lot of companies are working on that, on dealing with that. But is there more that can be done in that social layer where we can all align on that future vision of interoperability?
Yeah, I've been talking about this week, and I think there's actually a really easy, very straightforward fix to the social coordination problem, which is Ethereum adds to its roadmap a native-based rollup cluster, and they launch it with an interop solution, and they essentially force all of the other L2s to adopt this interop solution because it is the canonical interop solution that Ethereum has added to its roadmap. Now, this means that they have to be much more opinionated, right? They have to essentially eat into the market share that existing L2s have. But kind of coming back to Jordi's last point here, which I agree, in full. There's not going to be just 5 rollups, right? And this was the brilliance and genius of the original Ethereum roadmap that foresaw the need for horizontal scale, regardless of whether it was rollups or sharding. You knew that you needed to be able to scale linearly with new hardware. So I think that this future is there are many machines. Maybe there's not many rollups, but there's many machines running these state transition functions, and are interoperating across L2s. And I think Ethereum has an opportunity here to really spearhead a coordination effort by forcing them in sort of a soft power way to adopt a standard that they implement.
I think Ethereum needs to care. I mean, if he wants to be a layer 2, so the layer 1 for the layer 2s, he needs to be care to be an excellent, the best layer 1 as possible. I would say that probably in Ethereum, for the rollups, there is like 2 important things, 2 parameters that they need to improve. One, of course, is data availability. They need to increase, and here is where all the unshard and the sharding and all these blobs, I mean, all these process in there. And the other is faster finality. If for coordination between rollups, we need faster finality. If this is, Ethereum should care about these 2 things. Of course, maybe there are other things. Maybe need to care also what happens if there is some quantum but in the short term, I mean, for me, the thing is, if I were in Ethereum, I would care a lot in focusing, okay, what can we do to increase the bandwidth of the data availability? What can we do to reduce the finality? Right now, it's about 12 minutes or something like that, which is, I think it's 2 years, between 6 and 12 minutes. If we can reduce that finality, I don't know, to 20 seconds, that would be a huge advance for the rollups coordination. I know that's in the plan, but
I just want to chime in here, because do you really think that the interop problem or the fragmentation problem is just faster finality or bigger blocks?
I mean, if you want that the interoperability happen at the Ethereum level, definitely yes. If you are adding another layer, like the aggregation layer or something in the middle, then the problem is going to be in the middle. But if we want Ethereum to be, if we want all the rollups of all kinds to be on Ethereum, I think that having a high finality is an important thing, because you need to have some. I mean, when you are transferring information or value from one rollup to the other, one thing that you need. I mean, you cannot start using funds on another chain until the first chain is not committed. Okay, and where do you commit that? I mean, you can commit to some consensus, different consensus on Ethereum, or you can commit to consensus to Ethereum. But if you commit to consensus in order to start using that in the other chain, that means that this needs to be final in the layer 1. So this finality time, this is important if the coordination have to happen in Ethereum, which I think this is the easy solution. Okay. But we'll see. But it's not here right now. I mean, at this point, it's not really possible. It's not feasible. Having a friction of 12 minutes for many applications is just unacceptable.
Yeah, I think the one thing that a lot of tech stacks could do is like actually keep the EVM equivalents, like not just say it in marketing, but actually make sure that your tech stack does meet the EVM specification. because what you actually see underneath the hood is a lot of teams of like modified opcodes and precompiles. Avi, you mentioned like base native rollups, but like I think the only tech stack that's actually could be a native rollup today is the one we've built, because we were sort of dumb enough. I think maybe Jordi as well. We both actually took the road, like the path of like trying to, handwrite the constraint system for an EVM, and that's not many people are doing that anymore. So that's that's a big challenge, especially when you're talking about zk. But even optimistic, they're just like forks of OPGETH, and that makes that interop a lot harder. Like everyone has different state representations, everyone has actually different clients they're using. And so if we want to move towards that future of base native rollups, which again I think is like quite nice, there's definitely a lot of complexity there. But if we do move towards that with like more real time or one slot delayed snark proving to get like trusted zk interop, it's going to require a lot of these guys like actually putting back the EVM spec. And then some people might say, okay, well then you're limiting yourself to just EVM execution. And again, slightly controversial, but I just think that EVM is kind of good enough for pretty much all use cases that you need for a blockchain. So yeah, and if you really wanted to, you can add RISC-V, but yeah.
Well, this is that's why, again, it's not that, it's not disagree, but it's so that's why we are trying to remove the transition state function, the EVM in this case, from the, so each rollup should choose whatever state transition function. If they want to have a specific precompiles, they have a specific precompiles. Instead of using EVM, they want to use some WASM, they should be able to do it. If they want to do some application specific that's doing some decentralized whatever, and it's just a different state transition function, this gives a lot of flexibility to the rollups. Okay, and from the coordination, the important is not the execution, the state transition execution. What's important is the inputs and outputs. The communication with the other chains is this interaction with these other chains. And this is a much thinner interface. Agreeing on how we do transfers between one chain and the other is much, much, much simple that agreeing in which exact opcodes or which exact precompiles. So no, we need this precompile because we are using this corp, and there is a lot of debates on this and on that, and it's just give the chains the flexibility to implement whatever they want.
I guess that's the difference in like bets, is that I just don't think you need that much flexibility. So that's just a difference in opinion.
Just take the standard if you want. It's like, it's just giving the, if you are a normal chain and you are going good enough with the standard, you just pick the standard. But if you're a chain and you really need some core because you are interacting with some state cards that are using some specific corp or some specific RSA or some specific crypto, whatever, and you need to be optimal on that side, you should have the flexibility to have that.
I would just go back to Avi's point on Foundation could better coordinate some of these interop solutions, and I think there is for DeFi, and I'm coming from DeFi, so I have that perspective in mind. For DeFi, mainnet bridging would be fantastic, and I think we can use potentially the escape hatches for that, but we do need to have some forced coordination there, because optimistic rollups have this 7-day withdrawal delay window, which is very non-optimal, and capital flow is just very key. I think we are missing out on economic growth, to be honest, right now with the fragmented layer 2 rollups, and that's why we see higher growth potential in the Solana ecosystem. That would be also
awesome. Great perspectives. Very good feedback, especially if anyone from Ethereum is listening for that. Definitely.
Vitalik, where are you at?
But I guess for the final, observation question, is there anything that in regards to scaling, in regards to this, that is maybe overlooked in the space, that maybe needs maybe needs a bit more attention, or that you want people to essentially focus on? Like, is there any EIPs out there that are interesting to you, and maybe you want to see more of people looking into and experimenting with that?
I actually wanted to bring this up, but then we sidetracked a bit. So I wanted to bring it up that I think zkVMs and zkVM-based applications are really, really overlooked. And that's why I slightly disagree with Jordi, that there will be more rollups. We can also call these app chains. I think like a stateless app chain is the correct name, but there is so much unlocked there. And I know that all the zkVM participants, they are expecting that in the next year, every DeFi application will start using zkVM in their operation. But it's not much.
Yeah, I think the coming back to our previous conversation, kind of around like horizontal scaling versus vertical scaling. You know, do we have a few big rollups or do we have many thousands of rollups? I think I want to talk through like Nasdaq on chain, right? Which is Solana's kind of keynote application, North Star that they're going to run. You know, Nasdaq on chain. But you know, the irony is that you know the Nasdaq is not an application that is running over a single server as Solana is designed. The Nasdaq is a cluster of many servers that are running each market in parallel concurrently. And if you look across pretty much every you know computing paradigm, every wave of application programming, you see that there's a shift from the single server model to a distributed server model. And this is just strictly a problem of scale. And so I think what people you know, and the industry is eventually going to move towards, and I agree, it's probably not going to happen in the next, you know, 2 years or 3 years, but eventually we're going to get to the point where, you know, this interoperability problem isn't just because it's not a problem of moving assets across chains. It's a problem of distributing logic of a single application across as many servers as you possibly can. And again, this comes back to my previous point of, you know, it really depends on what your vision is here. What your, you know, what do you think the end state of all of this is? Are we building, you know, very niche financial applications that are going to be used by a few 100,000 or maybe a few million users, or are we building a, you know, a global financial system that is truly global and sort of unifies markets across the world? And if you think of the latter, it's like it is absurd to believe that, you know, the interop problem is just passing, you know, packets that represent tokens. It will be logic, and applications will run in a distributed setting.
I think that underestimates a bit like the potential for us to scale these like L2s though. Like anything Solana can do, like we can do better, as long as Ethereum scales the bandwidth. Like that's really going to be the bottleneck here. So yeah, I don't see a world where, like, again, it's a little bit, you know, maybe in the like 10 years time frame or more, like we have to go further. But I do think you can like put pretty much all the use cases that we foresee in crypto today on like extremely well vertically scaled L2s, and you only need like 3 to 5, and the rest is going to be, to Barna's point,
Dream bigger, dream bigger.
It's as I'm already dreaming big. It's just, you know, like you can put $1 billion on 5. It's what I think, and then the rest is just going to be, you know, like but maybe you call them like stateless app chains. Okay, that I would agree with then. Like, that just makes so much sense from like a technical perspective. Every architecture I've looked at, you know, you want to remove the overhead of a blockchain consensus from your costs. It's just a pain. So you might as well just use like a sort of stateless infra. And if we call that an app chain, then I agree there'll be thousands, but they won't be on these like shared state general purpose ones.
I mean, I have a concern, and maybe talking not as a Polygon co-founder, just as a community member that has been in the space for the last 10 years right now. Layer 2s are very centralized. And this is, for me, is a concern. I mean, it's not specific to anyone, but all of them, if you analyze the rate of decentralization that they have and you compare with Bitcoin and Ethereum, is much, much, much higher. This is a huge risk. Okay, fighting that is complex, because if you see the demand, I mean, if you see the applications, I mean, people don't care, and it's okay. You just care about the throughput, you care about the cost, you care, but it's like nobody cares. Okay, and if there is no demand, then the industry just tend to be more centralized, because I mean, the important is having high throughput, high finality, have high things, and you don't care about decentralizations. This at some point, this will break. I mean, this, we know centralized systems at some point they will break, and maybe it's the requirement. We need to break it to just building the things in the right way. But it's a concern. I mean, I just wanted to express this concern that unless we start paying attention more to decentralizing the infrastructures that we are building, this is going to collapse at some point.
Yeah, I think that's a fair point, but I think there needs to be a little bit more planning in that regard as well, because decentralization, like, first of all, I know that I would like to see the first decentralized sequencer. Right? So
Decentralization is like freedom. I mean, you don't appreciate it until you don't need it.
I agree with that, but it is still further away. And I think zk is a good middle ground as well, right? Because you have different decentralization properties on a zk application or a zk rollup with the sequencer, and like self-sequencing can sort of answer that. But yeah, I think that's a very good point, and I'm also concerned as a user. And it would be much easier for us to build a multi-rollup application if there is more decentralization, because right now we have to put a large amount of trust in the sequencer setup, that the sequencer keys are not compromised, components are not compromised, and we also need to monitor many systems, which is a technical overhead on our part.
Yeah, I'd really agree with that. Like, we're trying really hard to figure out the best path to decentralize Linea. Like, we did a lot of research around a decentralized L2, like QBFT with an outer protocol mechanism to make it permissionless. We're now doing a lot of the leading work on like based rollups. Again, that's very challenging with zk, and you have these things like pre-comps, which again are slightly better than centralized sequences, but like there's still, you know, a lot of complexity there to manage. So it's an absolute like top priority for us. I agree with Jordi.
Awesome. I guess we have a little bit of time. In terms of the centralized sequencer, there's been prover networks that have been created, and I guess like within zk, you know, once you have the proof, you essentially are guaranteed to run. I guess, would the same issues arise within the zk-based applications? Do you just need a wide enough prover network, or I guess like would that same issue of needing a decentralized sequencer apply?
I think like on zk, it's just liveness what you are talking about, because the proof already guarantees correct execution. So the prover network's point is more liveness, and to be able to build like a more decentralized application where you don't have like a centralized prover run by the team or zero, but have it decentralized. And the competition is very important there, because there is probably a huge amount of unlock right now that I think with Boundless, sorry, we are working with them. I'm a little bit, you know, subjective here, but they also expect, and I think it's true for everyone, they also expect when there is competition with these proven companies generating the proofs, it's going to get quicker. And that's the most important part.
Yeah, I agree. I mean, the prover is not the important part of the centralization. I mean, the prover, you just need to guarantee that the proof is generated. I mean, it's the liveness things that is important. And of course, I mean, worst thing that happen if it's a centralized prover and these guys stop doing the proof, and then the network stops. Okay, but they cannot steal funds. I mean, they cannot change the state. I mean, the prover cannot do anything. The only thing you need to guarantee is that the proof is generated. And I mean, there is one. And again, I mean, you can put just an incentive value, and if you put the right incentives, proofs are going to be generated. So for me, it's not the biggest concern on the prover. I mean, it's much more worse the sequencer, because sequencer, they can censor transactions, they can select one things, they can do a lot of crazy things. They can lie. I mean, it's much more complex, the sequencer part. The prover, I mean, I agree, there are these liveness things that need to think about, but it's not the most concerning thing, at least at this stage.
Maybe just one thing to add. So I think the important part though is that a lot of these proof systems still are like very immature. And so I think when we have a single proof, there's still like potential issues with like soundness bugs. We saw some recent zk systems have soundness bugs. So I think one thing that's really important is to have like a multi-prover zk rollup. And so like even ourselves, we have our own zkVM. By the end of the year, we plan to add at least 2 other zkVMs. So as long as there's like, you know, 2 out of 3 of these proofs, like sort of agree, then you still can make sure that if there's a bug in one, it's not going to completely like jeopardize the system. And especially if you're thinking about like decentralization, permission sequencing is even more important because you don't have these centralized protections.
Amazing. I think we're on time, but thank you for the wonderful discussion. Lots to think about in terms of Ethereum scaling. Thank you, everyone.
Thanks.